So remember, we always solve for the variables. This has an infinite number of solutions because it's a linear equation in two variables. So that the solutions go on for forever, right? But we have to get a number for the x as well as for the y at the same time, right? Okay, so each of these equals something. Someone said we can substitute in 0. Thank you, Lord Jean. It will be the x or the y intercept. And that's because, let's say I go ahead and make my x equal to 0. So I'm going to make me a little table over here to keep up with the solutions that I find. So when I input a 0 for x, what would the output be for y? Which is exactly basically what this is. So I'm going to go ahead and substitute in a 0 for my x coordinate plus 6y is equal to 18. Whenever you do that, now you're left with one variable, and I can solve for y. Okay? I can solve for y. We know anything times 0 is 0, so I'm just going to go ahead and write 6y is equal to 18. My last step to separate the 6 and the y is going to be what? Y is, I got Ashba, 30, y is 3. Writer, you said 36 and 3. Where would my 36 be? Is that for my x coordinate or is that for my y coordinate? So I'm going to divide both sides by 6. And then y is definitely equal to 3. Very good. So that's one solution that I can insert into this equation, and it would make it, yes, curly head. Hey, Lisa. It would make the equation a true statement. And that's what I'm looking for. I'm just looking for numbers that I can substitute in for x and y that would make this a true statement. Thank you, Chris. Okay. So someone said 36 and 3. Bonnie, yes. 18 divided by 6. Perfect. Blessing, the vertex is if we have a quadratic equation, something raised to the power of 2. You see now? Okay, very good. Somebody asked me to do 1. So is that going to be a 1 for the x or is that going to be a 1 for the y? Oh, good, Riley. Let x equal 1. You sure? Because I have a fraction, but we're going to see what we have. May not be too bad, right? So you want to substitute in a 1 for x. So walk me through the steps and tell me what I'm going to do. Lisa said y, so we'll do that one next time. Hey, August, welcome in. Hello. All right, so wherever I have an x at, I'm going to replace that with a 1. Plus 6y is equal to 18. Now 1/2 times 1 is 1/2 plus 6y is equal to 18. What do I need to do now? Since I have a fraction, I got to get my y by itself. What do I need to do from this step, from this point? I wish I had my other marker. I need to get a different color. Hopefully y'all can see orange when I start writing in orange. My blue is running out. Okay, so if I add 1/2 to both sides, this is going to make this be 2 over 2. Yes, I need to subtract because I need to do the opposite of adding. So I need to subtract. Perfect. Perfect, perfect, perfect. If I divide this by 2, perfect, perfect. Actually, I'm going to end up multiplying it by 2 if I wanted to get rid of the equations or divide everything by 1/2. So I'm going to go ahead and subtract 1/2 from both sides. The thing with that, see, I probably would have got rid of the fractions. This is why I wouldn't have used a 1. I would have used a number that would have eliminated this fraction, which would have been a 2. Because 1/2 times 2 would just go ahead and simplify that down. So Austin, when you say multiply by 2, am I only going to multiply 1/2 times 2? Or do I multiply everything in the equation by 2? So you have to be mindful of that. Right. We will multiply everything by 2 to get rid of the fractions. Absolutely correct. But I'm going to go ahead and finish it this way because that is the simpler way. Now I have 6y is equal to 18 minus 2 would end up being 17.5, which would end up being some ugly number because this would be 36 over 2, which would make that, what, 37 over 2? That's going to end up giving me a 37 over 2, right? If I change this into a common denominator, because the only way I can subtract fractions is a common denominator. So let me see, 18 and 18 is 36. Yeah, so that would end up being 37 over 2. I know. That's why I like to just go ahead and multiply both sides by 2. And then my last step will be to do what? But we know how to do this because we're like mathematicians, and so we're going to do it the more intense way. My last step to get y by itself is to do what? Divide by 6. Very good, Vonnie. So I'm going to divide both sides by 6, and I'm going to go ahead and do that so that it's easier to see. This is going to reduce down to 1, right? So y is equal to, and how do I divide fractions? Oh, I'm sorry, Mackenzie. How do I divide fractions? If you have a calculator, of course you can use it. But what's the rule for dividing fractions? Flip, okay? Very good, KCF. So instead of saying 37 divided by 6, it's going to be 37 over 2 times 1 over 6. Multiply by the reciprocal. Thank you, Javita. So, Vonnie, be careful. It would be multiplied by the reciprocal. So very, very close though. I know it's so hard to keep all these rules together. And so I would multiply straight across, and that would give me 37 over 12. Is there anything that I can do to reduce or simplify that fraction or anything like that? And we would probably go ahead and turn that into a mixed number because it'll just be easier to graph on the graph. So what would I simplify that down to? 37 divided by 12. What is it, 3 and 1/12? So fly, girl, you look so good to me. So 37 over 12 would simplify down to a mixed number, 3 and, I got 3 and 1/3, 3 and 1/12, 3 and 1/12. Okay. That's what I'm thinking, 3 and 1/12. So this would be at 3 and 1/12. That's why we have to be very careful when we're doing an equation that has fractions. You want to be careful about what numbers that you substitute in for the value of x. So kind of that you would eliminate getting a fraction as a point, which it is a solution, do not get me wrong. But what other number would help us like kind of get rid of that fraction? Oh, August, don't get nervous. Let me show you. Because of course we can multiply this entire equation by 2, but that's going to make that number really big. I could just substitute in numbers that simplify away. Yep. So I'm going to substitute in a 2 for that x instead. Can y'all see this orange? Does it show up okay? Okay. So now I'm going to put 1/2 times 2 plus 6y is equal to 18. And you can also substitute in values for y, but we just want to make sure that we get rid of this, okay? Now 1/2 times 2, what does that simplify down to? What happens when I multiply a fraction times the number that's in the denominator? A 1. So we know that this is just going to simplify down to 1. Don't have to. Like, we like good. Like, what's up? So I got 1 plus 6y is equal to 18. And remember that factor of 1 is there still. Hey, Lee. That simplified down to 1. Now what do I need to do? Still got to get y by itself. Subtract 1 from both sides. 6y is equal to 17. My last step is 2. Yes, very good, Naomi. Very good. Very good. Divide by 6. And then y is equal to 17 over 6. Or as a mixed number, this would be what? 6 and 2 will be 12. So that would be 2 and... what is that? 5 over 6? Yeah. So I still got an ugly little fraction. Very good. Excellent. All right, so y'all got kind of the motion that we... I think your name is Sierra, I guess. Jennifer, which one? Hey, Jennifer. The first answer, the 17 over 6. This one right here? Thank you for sharing the live, Aisha. Hi, Stephanie. 3 and 1/2, yeah. The 3 and 1/12 is, yeah, it would have to be 3 and 1/12. It would have to be 3 and 1/12. What, Sierra, you have to ask a question. Hey, Miss A. Somebody said try 4. So tell me what you get for 4. Are you going to put a 4 for the Y, or are you going to put a 4 for the S? Oh, you took your test yesterday, Vonnie? Good. Nope, I took Algebra 1 in 8th grade. I took Algebra, thank you, Lovey. I took Algebra 1 in 8th grade. Why? What you subtract to isolate the Y. Okay, well, just keep watching us. You always subtract you subtract everything, every number that needs to be removed unless it's being multiplied. You can't see this right here. Hey, Shay. Okay, somebody said they wanted to try a 4 for the Y. I'm using an old Motorola Android phone. This is my new phone. My old phone is probably about 4 or 5 years old. 4 years old. That's what I'm using right now. All my YouTube videos is on this old phone. That's it. And I got this little starlight right here. That's it. And I was trying to get one of them lights off of TikTok as a free sample, but they didn't send it to me. So I'm ended up having to buy me one. Yeah, it don't take much. That's all. Oh, I'm sorry. So, VB, you said substitute a 4 in for the X, right? You're welcome, Chris. For the Y or the X? You said 4 for the Y? All right, y'all substitute it in and tell me what you get. You are so welcome. So, they said they want to do 1/2 X plus 6 times 4 is equal to 18. What do y'all get for the output? We put a 4 in for the Y, so what are we going to get for the X? Shay? We are finding solutions. Remember, we can choose any number we want to for either variable, plug it in, and then solve for the other variable. Oh, A-OK, you are so kind. I need to, you know what? I'm going to put my little send me coffee thing up tonight when I get over here. I started it, but I didn't finish it yet. Once I get that done, I definitely will share it again. Y'all said subtract 12? You are so kind. I'm going to put it up tonight. 1/2 X. Y'all saying subtract 12, but what is this? Where y'all get the minus 12 from? What's 6 times 4? Yeah, we got to subtract. Oh, that's the answer. I was like, what? Okay, the answer is negative 12. My bad. I was so confused. Okay, plus 24 is equal to 18. Subtract 24 from both sides. We have 1/2 X is equal to 18 minus 24, which gives me a negative 6. And then I'm going to multiply both sides by 2. And X is equal to bada bing, bada boom. Y'all so smart. Y'all so smart. Right, Lee? Okay, so Sierra, let's go back up and look. Y'all got that thing. I see y'all. All right, so let's go back up real quick. I know I ran through that pretty fast. All right, so Sierra, let's list it up real quick. I have 1/2 X plus 24 is equal to 18. Can somebody tell Sierra what is the rule for when we want to get X by itself? It's multiple grades. Some people learn this in 7th grade, 8th grade, 9th grade. Some people do it in 10th grade. It's a lot of grades. Thank you, Chris. So at Sierra, we want to get Andrewski. Yes. So dividing by 1/2 is the same as multiplying by the reciprocal, which is 2. Good. I'm glad you feel better. So we just chose any number we wanted to choose and put it in the equation because you can do that. So you want to get the variable by itself. Okay, so listen up. So check this out. Some people like to do this horizontally. We need to remove everything off of this side. Think of this as a balance beam, and we have to do the same weight on both sides. So I'm going to go ahead and add a negative 24 over here, and I'm going to do a negative 24 over here, because that's the only way I can eliminate 24 is by creating a zero pair with opposite signs, right? So if I combine like terms, a positive 24 and a negative 24 cancel each other out. So now I have 1/2 x is equal to 18 minus 24, which is negative 6. Now, Drewski, we can definitely divide by 1/2 over here. But remember, dividing fractions is the same as multiplying by the reciprocal. Okay? So the opposite of multiplying 1/2 times x, Sierra, is going to be multiplying times 2 over 1, which is dividing by the divided by 1/2. X is then equal to same thing, multiply by the reciprocal, top, top, bottom, bottom. There is no denominator written that you can see, but it is 1. So that gives me a negative 12. So, yeah, so the reciprocal means flip that thing, numerator at the top, denominator at the bottom. Hey, DB. Yep, very good, y'all. It just means flip it. Hey, Neba. Hey, Nibia. Hey, Jazz. So somebody was saying they were having trouble whenever they had to cancel it out. So meaning you want to get an integer 0. Tay, hey, Tay. Thank y'all for sharing the live. Martin. You got it? Okay. What form is this, Cam? We're just solving solutions for this linear equation in 2 variables. We're just looking for solutions for a linear equation in 2 variables. That's all. Because remember, Shay, did you begin to understand when I said cancel it out? So what about that verbiage is kind of confusing you a little bit when it says cancel it out? Let's do another one that doesn't have a fraction, and let's find some solutions for that, okay? Let me do a linear equation in 2 variables that doesn't have a fraction. No, we haven't done one that had to do with slopes. Hey, Aisha, thank you. So, you said, have I ever done it? Oh yeah, we do. Hey hey NY, hey East Coast. Yeah, I do slope equation. Matter of fact, that actually, if I was to rearrange that into y equals mx plus b, that would have a slope. That would have a slope on it. All right, so let's look at this right here. Let's find solutions for this equation right here. Let's do y minus 2x is equal to negative 12. Oh, no. Let's not do that one. My bad. I found a better one. I like this one better. 2x plus 7y is equal to 5. Elementary math, Lena, some elementary math like fractions and stuff like that. I have, yep, Shaz, I have nonlinear on my YouTube page. Yep. Whatever you do to one side, you do to the other. So mx plus b, ASVAB, but I don't particularly know ASVAB, but Impact Math 19, she knows ASVAB. She actually has an ASVAB boot camp. Arik, it's on my page. If you go to my little page and click the YouTube button, it's on there. Hey, Lena and Unknown. Because it's my name, Sophia B. Math. It's the same thing. I don't do a lot of... You can find X or Y stars. So that's why we have our little table over here. You can substitute in a value for any variable that you want to and then solve for the missing variable. Oh, congratulations, Miguel. Congratulations on passing your test. Bomb.com. Go ahead. I don't teach matrix, Nikki. You're welcome, Miguel. Okay, so here we go. Remember, you didn't retain anything. So remember, this is a linear equation in two variables. We have to solve for x or we have to solve for y. But we need to give one of those variables a number. So let's just do something simple real quick. Let's go ahead and input a 0. And a lot of students, they're like, wait a minute, why am I just choosing random numbers? Because there's an infinite amount of solutions for this problem. So you can always just pick a number, plug it in, and then solve for the other number, okay? So whenever you're trying to find solutions for a linear equation, like for instance, if you need to graph a linear equation and you don't have a calculator, you can either rearrange it into y is equal to mx plus b, or you can solve for x and y intercepts and graph it that way. So if I substitute in a 0, I'm looking for the y-intercept. Let's go ahead and replace this x right here with a 0. This is an input-output chart as well. So I'm going to input a 0 in for my x because I want to see how the graph reacts. Oh, you can use a 1, you can use a 5, you can use a 10, you can use any number you want to. Any number you want to, because as long as it's a real number, it has a solution set. It has a pair to go with it. It's infinite. It's from positive infinity to negative infinity. A line goes both directions in both ways, and it never, goes both directions forever. Thank you, Morgan. Okay, so remember, when we get down to one variable, now I'm able to just solve for that one variable and isolate it and get it by itself. We know anything times 0 is going to be 2, so I can just go ahead and mark that out. Then I have 7y is equal to 5. My last step to isolate my variable, get it by itself, is to do what? I'm multiplying 7 times y. Divide by 7. Very good. Excellent. Divide both sides by 7. Then y is equal to 5 over 7. And I would write that in my table for a point that I would put on my graph. Right. Anything times 0 is 0. So that's why I didn't even write it. Anything times... Oh, did I say 2? My bad. Oh. It was an accident. Yeah, I did. Hey, I'm a BD. Thank you, Curry. Thank you, Kira. Oh, you said why do we use oh, you saw for why? Thank y'all. You said why did we use 7? Yep, I mess around and say the wrong number all the time. Sorry, my bad. Hey, I'ma be, thank you. So that's one solution. We can use 7 if you want to. But remember, this is actually a graph. This equation is representing a graph. I'm so glad you like it. This is actually representing a graph. So I would be able to, if you had a graphing calculator and you were to insert this equation, it would give you a line. It would give you some type of line. And that's what this is. We're finding solutions for linear equations. Ooh, Algebra 2, Cam. That's a little bit out of my league. So I'm going to go ahead and find the x-intercept. So I'm going to insert a 0 for y. Thank you, Lee. Thank you. She's been rocking with me for a while. So 2x plus 7 times 0 is equal to 5. Remember, anything times 0 is 0. I got it right this time, y'all. So I'm not even going to worry about writing that because I know that it's going to be 0. So that is equal to 5. And my last step here is to do what? I have to get x by itself. So I need to undo that 2 times x by doing what? Divide by 2. Perfect. This reduces down to a factor of 1, and then x is equal to 5 over 2, or you can write it as a mixed number or a decimal if it's a nice decimal. So this would end up being what? 2 and 1/2? You can also write it like that. Either way, because it's probably a little bit easier to graph on the coordinate plane if you use a mixed number versus an improper fraction. So for graphing, I prefer to use mixed numbers or even decimals because it's just easier to see. Thank y'all for liking the live. Hopefully y'all are learning something. Did anybody have any specific questions for tonight? I feel like, I've been talking for a long time, y'all. Anybody have any specific questions? We have about 18 more minutes. We found both the intercepts. Woo, 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 woo. Hey, Noob. Yes, it is definitely. Hey, Shy, welcome back. It's neat. I don't really do geometry, but Impact Math 19, she does geometry, and she has personal tutoring as well. Sine and cosines is out of my league right now. Sorry, I don't do trig. I haven't done that since pre-cal in high school. Oh, Lisa, I did. I answered your question. Yay! Good. I know I owe Lex. Lex sent me a question last night, and I was like, ooh, what type of geometry is it, though? Hard factoring. Okay. So Shad wants, I have 2 people that wants to do factoring. Are you talking about factoring trinomials? Ishan and Shad needs to do factoring trinomials. Hybrid says domain and range. Okay. So domain, Ishan, factoring. Okay. I actually did. I have a video. I want to say I have a video of factoring trinomials on my YouTube possibly. Hey, Nikki. So that was our little algebra lesson for tonight. Domain and range. I'm going to do that super quick and then we'll go into a couple factorings from... Oh, I do have one shot? Did you... Okay, I was wondering. Did you ask me about factoring last night? Was that you? So... Do you have a specific question about domain and range before I get started? Because I don't like just talking like with no... Hey, Chris. Hey, Dee. And Jenny. Okay, but you saw the one on the YouTube? Okay. Hybrid theory. Was there anything specific about domain and range? Because I have a video up about domain and range on my YouTube as well. How to find the x and the y, like of a graph or of a set of numbers? So you don't really graph the domain and range. Like for instance, real quick, and I'm gonna start factoring men. Let's say that you had a graph that went like this, and this was 0, 2. Your domain would be all of your x values, okay? Which means you're going to write down the numbers that the graph covers going horizontally, right? So since the graph does not expand past the 0, you're going to say that domain is greater than or equal to 0. Okay, so it's all real numbers that are greater than or equal to 0. That would be your domain. Now your range would be nothing lower than 2. So that means all real numbers that are greater than or equal to 2. You just have to find where the graph starts and stops. I'm just using any type of graph just to show him. I'm just using any type of graph. Good job, Lou. Good job. So this would be the set of numbers. Now, if you're talking like piecewise and stuff like that, I don't go that deep. That's a little bit too much for me. I don't know how to do derivatives. Sorry. Oh, you have a test tomorrow? Oh, good, Amberlyn. I hope I help. Are you okay? So go check my YouTube and go and check. Interval notation, 3M, Quan, absolutely. That, like I said, I don't do a lot of functions, though I do know how to find the domain and range of them. Hey, Miss S, that's all I know. Complex numbers, don't do those either, not too much. Beginning algebra. So does that help? And then I want you to go look at the YouTube for domain and range. Because like I said, I don't do a lot of it. I don't want to confuse you. Especially if you give me a set of numbers. And so sometimes it'll be a graph that skips. And it's just too much. Well, you should, 3 a.m. Okay, that helps. Because I want to kind of get everybody questions. And I'm going to do a couple factoring questions. And then if we have time for one more domain question, then cool. Y'all charged my phone up today. Lee, you still on here? Shad, are you still on here? And Ashan, are you still on here for factoring polynomials? Are y'all still on here? So the beginning of college algebra is beginning algebra, but y'all are gonna get a little bit more deeper than we are. So y'all are gonna go a little bit deeper. Do you need the first number to be a variable or no? I mean, the first variable to have a coefficient or no? Like for instance, do you need something like this? That? Oh my goodness, now we did a real big number last night. So it's gonna be the same though. Do you do the box method or do you do factor by grouping? Ooh, I can't do cube. I can, but I don't remember how. So I can't help you on that one, Shy. You a little bit above mine. Sorry. Hey, NTV. You do the box method? Okay. Yes, Tessa, we're factoring it. Hey, Tia. You know we want to mess up your name. Okay, so we're going to do 3 times 5, and that's going to give us negative 15. We're looking for two numbers that do what? So I got 3 times negative 5, which makes me have negative 15. Nope, it's not factored yet. So what do I do with these? I'm still looking for two numbers that equal a positive 14 in the middle. So I already know off top because it don't have that many factors. It'll be negative 1 and positive 15. You like the X method? I don't use that a whole lot. Oh, y'all was? And so Ishan said that he uses the box method. So what we're going to do is go ahead and put in our first and our last number in these boxes. And then you'll put the 1 and 15. It don't matter where you put them. But I'm going to put 15 right here. And I'm going to put negative 1 right here. Ma'am? Oh, you had polynomial quiz today? I did a negative number because I know 15 minus 1 is a positive 14. So it depends on what your middle number is equal to. Thank you, Shad. Thank you for the rose. You're so amazing. All right, so what you're going to do, we always find the GCF going all directions. So I'm going to look for the GCF between these two boxes. What's the GCF between 3 and 15? Oh, and actually this is supposed to be an X and this is supposed to be an X. Because remember, we're trying to make 14X, so forgive me. Always put your variables behind those two numbers that you are adding together to make that middle term. Okay? Yes. So my coefficient up here is going to be 3. And it's also going to be in x. So this will be 3x. Now, my coefficient going, or my GCF, my bad, y'all. Don't let me confuse y'all. I'm looking for the GCF. Hey, Selena. So I want to find the GCF all directions. So I'm going to go here. And then I'm also going to go this way. What's the GCF of 15 and negative 5? What's the GCF of 15 and negative 5 going vertically? It's going to be a negative 5. 5. Very good. And if we need to change the signs in a minute, we can, because I cannot right now remember what the rule is for your signs. Sorry. And then I need to go this way as well. What is my GCF between negative 1 and negative 5? What's my GCF? Hey, Melina. Just about I'm hungry. Negative 1, yes. It's going to be a negative 1, because if they're both negative, you have to take out a negative. It'll be negative 1. And then your last one is going to be your GCF going this way, which is going to be just what? What variable do they have in common? They only have a variable in common, which would be 1x. Very good. And you don't have to write the 1 at all. So now I have my numbers, 3x minus 1, and then x plus 5. And that would be your final answer. That would be it. Thank y'all. I'm sorry, I missed y'all's comments. I'm not paying it. I'm sorry. My back is turned. Hey, Nichelle. Welcome in. Hey, Adrian. Welcome in. Melina says she hates the box method. I'm sorry. I know somebody else just asked me to do an exponent greater than 3, and I do not want to mess y'all up because I have not done one, and I don't know how long. Expanding a log, I haven't done that in forever. Sorry. I'm so sorry. I apologize. And you said, how did I get a negative number? Oh, yeah, I told you. I already answered that. You don't have to do the box method. You can do... So do you do the guess and check method, or do you factor by grouping? I'm going to show you another one. What's a two-set equation? No, if I made this a negative 5, that would end up giving me a positive 5 at the end of my answer, and that wouldn't be correct. So to be 3 times x is 3x squared. 3 times 5 is positive 15, and then negative 1 times x is negative 1. And I need to add those like terms together to get me a positive 14. So I couldn't put a negative 5, okay? One more. Yeah, I don't multiply. Guess and check is your favorite. Divide and slide. I haven't got the divide and slide down yet. I always do the box method. Hey, Jay. Welcome in. All right, so we'll do one more of these. Cubed in, so you and Shad, or maybe Shad. No, you said it's S-H-A-A-D. You and Shad, right? Or I forgot. I'm sorry. Y'all are on a whole different level math. Let me do another one. And this time, like I said, you can definitely do a guess and check. I would have did a guess and check with this one, like the 3x squared minus 14x plus 14, no. Yeah, plus 14x minus 5. I definitely would have did a guess and check because, did I have it right? It's only like, it's not that many factors. So I definitely would have did a guess and check versus doing the box method. But I knew that was the method that he used. Look, I got a whole little paper. Somebody had me doing these the other day. And she had big numbers. I had to tutor somebody last year doing this. She was in business math. Factoring quadratic equations. Look at that. The X method, you can definitely use. Okay, let me do one of hers. And hers would have big numbers. Let me see. And she did the box method because it was so big. Like, hers was... It's not too bad. This one is not bad either because it's not a whole lot of factors for 30. But, hey, Adrian. Okay, I'll see you tomorrow. I'm glad you stopped by. You like factoring? Long division? Ashawn, you said cubed. What you mean by cubed? Is what cubed? Yeah, the diamond. Yeah, we can act. Yeah, you can definitely do the... They call it the X, where you put, what is it, 30 up here and then 4 down here. But with this one, you still have to do 30 times -4. So this one is a little bit different because you end up getting 120. So it'll be 120 and -14. And you're looking for two numbers that multiply to make 120 but add together to be -14. It's an extra step with this one. I like grouping as well. Grouping is my thing. I always use the grouping method. Somebody says slide and divide. I've only heard of that like 1 or 2 times. So Nisi, it's called the AC method. And I'm just going to multiply the first and last digit, and I'm going to get a -120. And then I'm going to find two numbers that add up to make -14. So I'm looking for two numbers that add up to make -14 since it's -120. And then you just go through the list of factors. Yep. All right, Ashawn, and y'all solve it whichever way y'all want to solve it. I'm going to do this one factor by grouping. And then we'll be done. You said 7. Can you take out a 2? Yeah, I could have took out a 2. I could have took out a 2 at the beginning. And I just got to remember to write the 2 down at the bottom. You want to do the box method? So, yeah, you could have absolutely divided everything by -2 and made that 15x -7 -2. But you just got to remember to put that 2 at the bottom and don't forget. So, do y'all want to do that first? Because that is how you do it. You always have to factor out the GCF. Good job by catching that. I just went straight into the to the multiplication and the division. -20 and 6. Very good. Oh, George, I have a completing the square problem on my page. I'm not the expert at that. I can do it, but it takes me a while. So, crib, -20. Oh, Nisi, I'm not the best at the diamond method. -20 and 6. So I got -20 and a +6. So we'll do factor by grouping, and then I'll try to, so it'll be the same thing. So you got your X, you got a -20 up here, and a -14 here. So you got -20 and +6, right? And then from here, honey, I don't even know what to do. For the diamond method, I'm not even going to tell you no tell. It is. So I'm going to do the factor by grouping. So we got 3x. Oh, wait, my bad. You wanted to do the box method? Y'all want to do the box method, right, Shad? My bad. Let's take out the GCF. I mean the box. Yeah, we did 30 times -4 and got -120. said divide everything by -2 at the end. Don't you see that's what we're doing? All right, so now we got to find the GCF. So find the GCF of these two boxes going this way. So what's the GCF of 30x squared and 20x? It is. It can be kind of tedious. 10x. Very good. So I put 10x here. And what's the GCF for 6x and -4? Very good. What's the GCF for 6x and 4? 2. Okay. Now, since I got these that way, I'm going to go this way. What's the GCF for 6x and 30x squared? You just find the GCF in all directions. All four sides is going to be 6x. And then my GCF for -4 and -20 would be, and pay attention to your signs. Yeah. First of all, I'm not a girl, I'm a woman. -4. All right. So you would write these in your parentheses, and you would have 10x squared plus 2 times 6x minus 4. But if you see, it's not completely simplified because there's still a GCF in the factors. Okay, there's still a GCF. Leebu, you so funny. Yep, 2. So I'm going to go ahead and pull out a 2 from my factors because remember these are being multiplied together. So I'm going to go ahead and factor out a 2. My GCF from all my factors is a 2. So then that would leave me with, remember we divide both of these by 2, divide by 2. That would give me 5x squared plus 1 times 3x minus 2. Right, because I'm a whole one with, yeah. This is the box Betty. Yes, Takara, I'm sorry. They could have been being nice, I don't know, but I said I need to stop being so spicy. I'm gonna do better. So, so glad. Oh, I did. My bad. I put an X. There you go. She said they can make a new page with a new attitude. Oh, I bet it does. I bet it does. I haven't done this with Cube before, so I couldn't even tell you. I haven't done this with Cube before, so I couldn't even tell you. This is what you're doing on your homework? That's because I put the wrong thing. I just put a 2 on accident. I mean, all right. You have a good idea now? That's all. Sometimes I write the wrong thing. Sometimes I get messed up. It happens, y'all. And I did a -4 instead of a -2 because the GCF is -4. We don't want just any factor. We want the GCF. Hey, Tressa. Aw, man. Hey, Tressa. I'm sorry. My bad. My bad. Are you just not joining? not joining? I'm sorry. My bad. Thank you, Navy. Thank you, thank you, thank you. So you are welcome. Very, 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 very welcome. Yeah, the box method is. You said redo the box method for Tressa. Okay, yeah. All right, last one because it's 9:07. We gotta bust up on up out of here in a minute. Let me see here. Let me see if I can find one more Tressor. Let's see here. Let's see here. Let's see here. What can we do? Which one can we do? We'll do one that's not so big. 8x squared. Is this minus 14? Yeah, I think it's minus 14x plus 5. So this one isn't as big. Oh, it didn't? I'm sorry. Because it should have gave you a, what's the name? It's just beginning algebra. It's just beginning algebra. Hey, Mariah. A square root equation? I don't have one. Yeah, this will be our last one. Ooh, differential equations. Ooh. Okay. So same thing. We still have to get our numbers. Ooh, I don't have the absolute volume. So what do we do with this one? Factoring, yep. Factoring, yep. Somebody talk about the Smiley's method. Remember, y'all wanted to do the box method, but I got to do something. The very first step is to do what? What's the very first step? Remember, we have to make this into 4 variables, 4 terms. Yeah, so we're going to have to do 8 times 5 and get 40. And then I'm looking for 2 numbers that make negative 14. 2 numbers that make negative 14. Thank you, Flawless. 2 numbers that make negative 14. What 2 numbers make negative 14? Negative 10 and negative 4. And remember those as negative 10x and negative 4x. But remember, they have to multiply to make 40 though. Yeah. So now I got to put 8x squared here. 5 goes here. Negative 10x and negative 4x. So 7 and 2 don't add up to be 14. They have to add up. So they multiply to make 40, and then they add to make negative 14x. So that's what I'm looking for. Oh, that's okay. You remember? Good. Hey, CS Money, thank you. Okay. Same thing. We're just looking for so you want to find the GCF going vertically, and you want to find the GCF going horizontally. Oh, you do? Good. Oh, yay, Nephew, yay. All right, so what's my GCF between 8x squared and 10x? What's going to be my GCF? Two. Okay, 2 and what else? They also have a variable in common. X. Okay, and what would be my GCF of negative 4x and 5? Do I have a GCF going that way? That don't be making sense. Just a 1. And then what about going vertically? Do I have a GCF? What's my GCF between 8x squared and negative 4x? What's my GCF? So the greatest common factor, your greatest common factor. So the biggest number that they have in common when they're being like, what are the numbers that you multiply to get 4? The numbers that you multiply to get 8. I can multiply 4 times 1, and then 4 times 2. So their GCF is 4, and don't forget the x. Don't forget the x. Very good. And then what about right here? In the negatives, let me remember, because I think if this is double negative, I don't know if both of them are going to be negative or just one. I have to remember. Oh, Vandal, you're so kind. Because I have some people saying it's negative 4x, but my leading coefficient usually isn't negative. Thank you for sharing the live. So what's going to be my GCF? 5, okay? And here, I have to be careful about my signs because something is going to have to be negative, right? So when I get ready to write my answer, I have 2x and a 1. Then I have 4x and a 5. Now, if this is positive, that means both of these are negative. Since I have both negatives here, so I have both negatives here. Because when I add them together, I need a negative answer. But when I multiply them, I need a positive. And I forgot the rule for your signs. I just totally forgot. So this actually then should be a negative 5. And then this would be a negative 1. But I always forget to make sure what signs go where. Hey, Raha, we about to get off of here. You came right on time. We about to... Oh, you fine. Thank you for sharing the live. Does that make more sense? Tressor? I hope so. I think the last one we had a lot going on. You're welcome, Sasha. I think one of our numbers wasn't right. I don't know. Y'all get the gist of it, though. Find the GCF. Oh, really? I didn't even pay attention. Yeah, I like factor by grouping. I don't know a lot of algebra, too. I know a little bit, but not a lot. A little bit. I do mostly like pre-algebra, beginning algebra. Right, Tressor. Is it Tressor or Tressor? You're welcome, Lisa. Probably by 8 o'clock. I try to get on about 8 o'clock. 8:15 maybe. I know y'all was getting it in last night. I don't know who been on here today. Thank y'all. I really appreciate it. Y'all are so good. Oh, Shaprisa is not on here today. I was going to ask her. She asked me to put something in the TikTok shop, and I have no idea what it was. I see my video I put up, but they messed it up. The negatives, okay, yeah. So it's a rule, but I forgot. I don't remember because I don't never use this.